Okay, so today we're going to be finishing out all the part tools that we're going to be covering in this workshop. So we're going to start with talking a little bit about Hole Wizard, and then we'll show you guys about sweeps and loss to finish that up. So Hole Wizard, basically what it allows you to do is set up standardized hole sizes, which is super useful when you're talking about putting bolts through things. So you can see on our fin rings from this past year, we used it to good effect. So these holes need to be clearance for a number 8 bolt. So that is 0.169 inches or something specific. And you'll need to remember those dimensions for every single bolt size if you want to just be able to make a hole sketch and cut it away. But Hole Wizard includes all of that information for you, so you just need to select the bolt size and what kind of fit you want for it. Same with these. These are tapped holes for number 8, so then that's like a 0.136 inch drill diameter that you need to cut that hole. So again, lots of numbers to remember, kind of hard to do, so we tend to avoid it. So how to do the Hole Wizard is you need to start with the body, obviously, so we can just extrude out a block here to work on. Doesn't have to be dimensioned or anything. And we come up here and select Hole Wizard. And Hole Wizard will give us a couple of options. The thing that pops up first is the type of hole, which we'll get into in a second, but we'll start by switching over to positions. So you can either take a sketch and import that into Hole Wizard. So you would just select it here and then use that as the basis of the hole positioning, or you can just create a new sketch within the tool. So in this case, it says select the face to do the sketch on, so we'll just select the top face of this. And you can press Control-8 if you want. And you'll see, contrary to what usually happens when you open a sketch, it opens up with the point tool selected because Hole Wizard puts holes wherever you put points on your part. So if you're going to import from another sketch, you would just come up here and put points wherever you want your holes to be. Then when you click on the sketch, when you open up Hole Wizard, it'll automatically put the holes wherever you want. But otherwise, you can do everything else that you would want to be doing in a sketch, dimensioning things, what have you. Leave the other ones on dimension for now. And once you have your whole position set up, you can come back over to type. And there are a whole bunch of different types of holes that Hole Wizard lets you do. The main ones we'll be using are tapped holes, or calls it straight tap, and just regular holes. So a regular hole, you'll have the option of what standard you want to use. Everything we do is in ANSI inch. You can do ANSI metric if you're using metric bolts, and then obviously a whole bunch of other standards that we don't need to worry about. And then it'll give you options for type, which again, there are a whole bunch of things. So all drill sizes, that will pop up a list of every single drill that is commonly used from a number 97, which got to be like microscopic basically, all the way to 1 inch. And this is useful, so we can say that the clearance for a 1/4 bolt is like a P drill or something like that. But that's still annoying to have to remember like the drill letters or numbers or whatever. So you also have the option to do fractional drill sizes, which gets rid of the numbers. And yeah, a whole bunch of other ones. But the main one we'll be using are screw clearances. So the way screw clearances work is you tell the software the size of screw. So that goes from number 40 to 4 inch. In this case, let's just stick with the number 8 size. And then there are 3 options, close, normal, and loose for the actual fit. So if you need anything with positional accuracy, you'll want to select a close or semi-accurate position or locating. You'll want to select a close fit. If this is just something that needs to compress together, you can select a loose fit. or you can just go with normal if you don't want either. Normally we stick to close or normal. So let me another quarter 20 better. So a close fit for this is 0.257 and a normal fit is 0.266. So we'll set that on close, and then if we make the hole, you'll just see there are 3 holes that show up, and they'll all be at whatever the dimensions we set are. And this also makes it really easy to go back and look at your parts and determine like, oh, this is a clearance hole because it says it right here, but I actually need to have this tapped. So then you'll know, okay, that's wrong. I need to go back and edit that feature. And we can switch to straight tap, and same kind of thing. We'll just go with a tapped hole. A bottoming tap is a special kind of tap that basically cuts the threads deeper than you otherwise could if you're going into like a blind hole where you're hitting a bottom. But those are, you know, expensive, specialized, so we just tend to use the regular tapped holes. And again, you'll select the size that you want. And in this case, along with the size is the actual pitch, right? That's per inch of the part. So 832 is number 8 bolt diameter and 32 threads per inch. And if you open up custom sizing here, you'll see like a number 8 clearance is 0.1695 or something. Number 8 nominal is also similar to 0.16, somewhere around there. But the tap drill size is 0.136. And that's because you need to cut the hole undersize so that when you tap the hole, you can form the threads so the bolt can actually fit in there. So I'm gonna do that. Again, we just get these. So by default, it pops up with this little dotted line around holes that have a thread on them. You can change that to be a cosmetic thread where it's just pull up the appearance here. It's not showing up too great in there, but it just like shades the face of the part to kind of look like a thread, which is better than having an actual like thread geometry in the hole, because then you get a lot of faces and your CAD can slow down if you have like a whole bunch of bolts, which is something we run into in past assemblies for rockets, because all the McMaster parts we use are like fully modeled with the thread geometry. So if you see these dotted lines, that just means it's a tapped hole. And again, you can come over to the feature tree and see what size tapped hole it is. Yeah, so that's about it for hole wizard stuff. You can do more complicated things like putting the sketch on a 3D surface. So let's say around the outside of the tube or of a tube. That's just not something we're going to cover in this workshop. So yeah, let's move on to talking about sweeps and lofts. So we'll start with lofts because they're probably more common than sweeps. But basically what it allows you to do is connect to different sketches or closed surfaces of different shapes. So let's say I wanted to start here on my top plane, make a circle, and then we'll come up here as I showed last week. You can create new reference geometry to start sketches on. In this case, we'll look at the top plane and bring it up an inch is good. This is just a demo, so the exact dimensions don't really matter. But again, you can start a sketch on this plane now. Control 8 will bring you normal to the sketch, and we can select a different shape. So let's do a rectangle, and we'll close that out. So if I wanted to create geometry to connect these two with like revolves or an extrude, that would be pretty complicated, possibly impossible, depending on the exact geometry. But with lofts, again, right up here, all you have to do is select the starting profile and the ending profile. And then you get this nice geometry that connects the two. It's a pretty simple tool to like understand how it works, and you can get very, very complicated with it. So let me stand this off a little bit more, like 5 inches. And there are options to do guide curves. So if I roll my feature tree back a little bit to before I made, the loft absorbs the sketches, which is kind of annoying sometimes. So I'll just leave the sketches open. Bring that up again. So you can make guide curves for the actual loft. So let's say instead of just wanting this to go straight from this surface to this surface, I want it to like come out at an angle a little bit. So I can make a sketch on front plane, right plane, whichever one. In this case, I'll just make a spline because it's easy, but you know, splines are generally something to be avoided unless you need them, because they're really hard to dimension. But there's a spline. I'll make a construction. I'm not actually sure that you are required to make a construction, but so again, you can come over to lofted boss base in the top of the features tree, or the features command window, and we'll select our profiles as normal. And then I'll select the guide curves in the middle, bring me a checkbox. It doesn't want me to. Maybe I have to make a not construction. Interesting. Well, I don't know why it's trying to be annoying with me. Oh, I think maybe I have to actually go from point to point on the sketch. So yeah, that's an advanced thing. I don't really use it that much, so hence why I don't know how to do it correctly. I guess the other thing that might be useful for you guys, let's say I were to make this just a different size square. So now we have points on. I don't know why this is being annoying with me. But basically now we have 4 points on the top and bottom. Those relations showed up. And the thing you can do with lofts is change the twist. So let's say I wanted to have this twist as it goes up. So you can see these green points. I can drag them and it'll basically link whichever 2 corners the parts are on. So I can drag that all the way around and it'll break. But if you want a twist, that's how you would do it. Again, it's probably more complicated than anything you guys will be asked to do, but I know it's there. Sometimes when you actually create the loft, it'll be like the 2 lines will be across each other like that, and you'll say, I don't know what's going on. So now you know, you just need to drag these green circles in line. And that's a loft. It's useful for lots of things. So I don't know if this is recording my camera, but I have a water bottle here that has like these grooves on the bottom. These would be pretty complicated to try and do. You might be able to get away with like putting a revolve and cutting out this profile like that, but it would be complicated. So instead, what you can do, you can see here, I have a bottom sketch which has those indents sketched onto it, and I have a top sketch that's just a normal circle. And when I do this loft, it's kind of hard to see. Some tools like zebra stripes will help you see what the curvature of your part is doing to a certain degree, but it has these indents that start on the bottom, and then as they move up, it just makes a normal circle. So useful stuff there. The classic examples that you'll see people do in CAD are like water bottles and detergent bottles and most bottles, honestly, because they have the generally curved shape. So that's lofts. The other thing that we're going to talk about is sweeps. So, I guess before we do that, obviously you can extend lofts to be as complicated as you want. This is absolutely terrible, like CAD work, but we just needed a workaround to get this part made. So this is a one blade of a prop for a drone propeller. So you can see here, I just have a whole bunch of sketches, which are all splines and completely undimensioned. But you can just create a whole bunch of cross sections. And then I just lofted between all of them to create this blade shape. It's also commonly used. So like aircraft fuselages are defined by the station on the aircraft and the shape at that station, which is basically exactly the same thing. So it's a distance from whatever it is, the nose of the aircraft, the wing chord or whatever. And each distance will have a cross section associated with it. So you can draw all those cross sections and then loft between them, and you get the shape of the aircraft. So yeah, that's how lofts can be useful. They are quite useful for designing propellers and stuff like that. Usually you won't have like splines and stuff. You'll actually have defined shapes for them, but yeah. Otherwise, yeah, let's go and look at sweeps for a second. So sweeps require the same things. You can see both lofts and sweeps are grayed out initially because you need a sketch profile, or really two sketch profiles for each of them to actually make them. But all a sweep does is take a profile that you draw, so it can be a circle, it can be whatever abstract shape you're interested in, and pulls it along a line that you've also drawn. So classic example with that is a paperclip, so we'll do that now. So let's start on the top plane and we can make the actual profile of our paperclip. So that's just a line followed by an arc, followed by another line, another arc, and I don't have a very good one on hand, but I think they go one more over. That looks right. And down a little bit. So this is your 2D projection of what a paperclip looks like, just with lines. So we can exit that sketch here. Again, you'd want to dimension this, obviously, but just for showing you how to use the tool, we'll leave it open. So I started this sketch at the origin here. So I want to draw my profile in the direction that it's going to be extruded. So we want to take a little circle here and pull it along this line. So we'll start the sketch on the front plane. And you always have to make sure that your profile intersects with the start/end point of the guide curve that you're sweeping your part along. So we'll just do a circle. Doesn't have to be that big. Now we can come up here and do sweep off space. It asks us for a sketch profile. So you can see two options here. One is the profile, that's that little circle we made. One is the path, which is the curve we made. And you can see it pretty much just makes itself. I'm remembering now that there's also just an option to do a circular profile with SolidWorks, so you can just set the dimensions to whatever you want. So that's useful for making simple parts. But yeah, and you create it and you get a little paperclip. So again, you can get a lot more complicated with the sweeps. And a little bit more freeform in certain ways. So again, you can have guide curves. So let's say I wanted to have this paperclip be like a smaller diameter at some parts and a larger diameter at others, then I could create a guide curve and it would change the direction that this curve follows. You can also do twists, so obviously it won't do this because I have a circular profile right now, but let's change that to be a square. Rectangle at the very least. And we can edit the sweep again. And let's say I want it to twist. I say I want it to twist 90 degrees over the entire length of it. So you can see it starts like that and twists all the way. And I can do way more than that. I can do 60 or whatever. And then it'll twist twice all the way around. So probably not useful for a paperclip, but useful in some aspects. And finally, there are some other things you can do. Setting the profile orientation. So you can see in this case, if I set it to keep normal constant, it fails because what that is trying to do is keep this profile always facing in the same direction as it follows this curve. So obviously once it hits the top of this arc here, then it's zero thickness geometry, so it just doesn't handle that. But if I was just keeping it all in the same direction, then theoretically it could have a constant like profile from looking from a single direction. And yeah, both the loft and sweep have these options for start and end tangency. So in this case, it's going to not do anything. Let me edit this so it will do something. We'll make this curve our path and at an angle over here. So I can edit the sweep again. And we can say start and end tangency. So well, I made this pretty much exactly 90 degrees. So let's change that. Edit this feature again. Start and end tangency, I can select path tangent or none. So it's not doing what I'm expecting it to do. That's interesting. Well, normally what it would let you to do is set, like sometimes it might end with, like the profile might continue along and be flat, like the same way that it started here. But if I want this to end at an angle, normally you would select path tangent and then it would stay normal to the path throughout the entire thing, but not doing that for me. I don't know why. Sweep tools are definitely, sweeps and lofts are definitely less common to use, but they're powerful for certain applications. So the other place that we used a sweep and a loft was for our fins here. So technically this didn't need to be a sweep, but it made it a little bit easier for the ends here. So the way this works is we have our fin core here, and then we wanted to have a 3D printed leading edge with a little bit of a round on it. And that just gets epoxied in and then covered with the carbon fiber. But I made a sketch to do, that was the profile we wanted. It's just a little rounded thing. And I swept that. The other thing you can do with sweeps is you don't have to make a sketch for the path. You can select existing geometry. So I just selected the actual curve of this thing as the path. So I swept that along the straight side. Again, theoretically, this could have been an extrude. I would have had to start it normal to the actual line that I'm trying to extrude it on, and then cut off the excess or add back in the excess, I suppose, at the end here. So a sweep just made that a little bit easier. But we get this nice profile that follows the the leading edge of the fin. And now we get here, and this this foam isn't going to have this round cut into it on the bottom. So we need to transition between the rounded face of the leading edge and the flat face of the trailing edge. So to do that, we can just do a loft. And again, in this case, I didn't actually draw any profile curves. I just used the existing geometry of the part, this ending face and this, or the starting face and this ending face over here. And then I use the guide curve. I use also the curve of the part to make sure that it followed that nicely. So you can see we get a smooth transition from the rounded edge of the leading edge to the square edge of the trailing edge here. And here, so now showing you how those guide curves work. If I deleted it, it would just do shortest path from one section to another. But having guide curves, and yeah, you need it not in the middle like I had it initially, but on one of these corners between any point that those two green dots could attach to. I select that, then it will follow that curve. And again, we can move these dots if we want to. There's some other things that needed to be taken into consideration with this specific setup. So here we're going from a rectangle, or we're going from this curve thing, which has 5 points vertices that define it, to a rectangle, which normally only has 4. So you'll see when I made this, I actually had to split the profile here and add an extra point in the middle. Otherwise, SolidWorks kind of freaks out and says, okay, you're going from a surface with 5 points to one with 4. I'm going to twist something or do something weird. So sometimes you have to do that if you're getting weird twists or anything with your part, but it's a pretty simple thing to just add a little split face or a split line in there so that the number of vertices match. Yeah, that's an application for a loft and a sweep, I suppose. This specific use case for it, as far as the engineering purpose, was probably a little bit less than useful, but hey, it's here. So yeah, that's pretty much all that I feel the need to cover with sketch or with part tools. I guess there are a couple more things. So this set of tools over here, I've shown you mirror. That's pretty self-explanatory, linear pattern, filled, and chamfer. There are some other ones. I think the most common one I've used is shell. And basically that just lets you take, so this is a complex geometry. Let's say I wanted to make this the actual bottom of the water bottle. So I obviously need a cavity. If I wanted to have like a constant wall thickness here with an extrude, or I suppose I'd have to make another loft sketch and profile here to match, but be a little bit offset from this. So I mean, that would look something like this. And I can just, so they're not in our way, but make another sketch on this top face, hit offset entities up here and select this. Reverse 0.1 inches is fine. And that'll just make a new sketch or a new line that is 0.1 inches offset. We'll do the same on the bottom, excuse me. Obviously, this would be a lot harder to do than just another circle. So this is really a good use case for the offset tool. And actually, sorry, we're going to have to offset, make another plane so that this doesn't go all the way through the bottom. So we'll make a new reference geometry based off that. We'll set it 0.1 inches above that line. And we'll make our offset sketch on that. And there we go. So now, having done those two sketches, I can loft between them And I'll do a lofted cut this time. So again, same kind of thing, difference between extruded boss base and extruded cut. You can also do lofts and lofted cuts, but I'll do that. And we add some fillets and stuff to match the ones I did on the outside, but that's one way to get a constant wall profile on something like that. But obviously, as you get more complicated parts, that can get really annoying to do, and it is pretty annoying even with just that. So let's delete those, and I'll show you the better way to do it, which is with the shell tool. The shell tool literally just makes things have a constant geometry. So point 1, I select the face that I want to do the shelling on. So the face that you do the shell on will be open on one end, everything else will be closed. But you just hit OK. And there we get everything already done, all with the fillets that I had already in there. So useful tool for creating like electronics or really just any kind of container of simple or complex profiles, because you can make sure sometimes if you're making like a curved container, it can be kind of hard to make sure that the wall thickness stays constant, like throughout fillets on the bottom or on the sides or anything like that. This, all it does is ensures that you will always have a constant wall thickness, which is really great for like injection molded parts where having different size wall thicknesses can really cause a lot of warping and stuff like that. Not something we're doing, but something to keep in mind if you ever run into it. So yeah, that's the shell tool. There are also some other ones. Rib, I've seen people use. Normally, I just find it easier to kind of extrude. Basically what it does, and let me even see if I can remember how to do this. Let's go to a simpler part here and just extrude a little block for us to work off of. So I believe the trick with ribs is you draw a kind of angled profile of it. So we'll select the front plane here, do a sketch on that. We'll convert this wall and this wall. I can have a place to start my line. And I'll just trim these down and make those sketch geometry, structure geometry, excuse me. So yeah, once you have a line like that, then you come up and hit rib and you just select that line, yeah. And you can set the thickness and the direction. So the direction you want to extrude, I obviously want to make this a enclosed rib, so we're going down. The thickness you can set either as like a midline from the line you drew, one side or the other. But you just do that and then you get a nice little rib. Yeah, in general, when I've used it, it's been easier to just make an extrude like that sketch and extrude it outwards. You can do like a symmetric extrude if you want to get the same properties, but there are certain cases where it can be more useful to do a rib. And the last thing is we can talk about drafts a little bit. So a draft angle is just an angle on your on a given face. Again, really most useful for like injection molding, because if you ever look at an injection molded part, you can kind of analyze it and see how it was designed. But when it comes out of the mold, you don't want to have it have 90-degree angles on the faces that it's sliding out with, because then it's really prone to binding. Whereas if you have the angles have a little bit of a draft in and then you're pulling it out of the mold, as soon as you move it, air can get in, so you're not like pulling a vacuum on the backside and you're not having any friction because the wall's not in contact anymore. So having like a 1, 2, 3 degree draft Yeah, if you look at injection molded parts, you'll pretty much always see them, like Legos. I think are the prime example. I believe how they do it is like on the internal circles on the bottom of the parts that the little dots lock into. I don't know the correct terminology, but those have a draft angle on them. So when they get pulled out, it just comes straight off. And obviously the external faces of the Lego brick do not, because you want those to match up with all the other Lego bricks. So anyway, how this works is you select, geez, what do? You select a face for a direction and then the face you want to draft. And then I'll exaggerate this so we can actually see it, but you can see there we get a little angle on the part. And I believe this works. The reason why you would do that and not just like make an extrude of this profile is you can also do it on curved sections. So let's just pull a part out like that. And again, if there's stuff that I'm doing with like creating these features that I'm working with that you're having trouble with, go back to the previous videos. But yeah, we can select the draft, we can select our profile again, and then that, bump that down a little bit. But yeah, so we can make a profile like this, which is also something you could do with a loft, incidentally. Change between two different parts of a constant profile, or with a revolve, if it's a constant circular profile. So yeah. And I don't expect you guys to be using ribs or drafts. Shells might be more commonly used. But yeah, and then wraps and intersects are not something. That's a topic we might cover in the advanced class. But yeah, that's pretty much all I had for today. As always, let me know if you have any questions, and I will see you guys for the next one.